And small changes in the way you treat your battery today can have a massive impact on what's happening in 10 to 15 years.
What's gone on in the last 10 years of battery cell chemistry and what's coming?
And then boom, they just threw all of their experience into scaling it up, and that was massive success.
What's the other curveball that's coming down the way from a battery cell chemistry perspective?
It's really the one technology that I believe has everything it takes to be wildly successful.
Accelerating emerging technology like battery cells, the control and the power is still in the manufacturer's hands. Are you saying that you guys can change that using data?
Contrarian enough?
My brain's broken.
Hello everybody and welcome back to another episode of Modo, the podcast. Today, Quentin is talking to Dr. KP Kyries, CEO of Accure Battery Intelligence. Over the conversation, they discuss the ins and outs of different cell technologies and how using data can help improve the lifetime and performance of a battery. As always, if you are enjoying the podcast, please hit like and subscribe. It really means the world to us. Let's jump in.
KP, do you want to talk about Accure then? How long have you been doing Accure?
For a couple of years. Officially, it's 3, unofficially around 5, I guess.
What was the idea? Why did you start Accure?
You know, my background's in electrical engineering. I've been doing batteries for over 15 years now. And in my last job, I was leading one of the largest research groups on stationary battery systems in the world, maybe even the largest one, for a few years. And I was really frustrated that no one's using battery data in a meaningful way. And I was always hoping that some company would knock on our door and say, hey, university folks, do you want to do a research project with us to get us on track? And no one knocked. And then I said, okay, seems like we have to do it ourselves.
And you're a doctor, right? You've got a PhD in something technical. What's that? That's battery related, right?
Exactly. Something technical. It's a PhD on lithium-ion batteries for stationary use cases. And in my PhD, I wrote, like, it's not the most technical dissertation that has ever been, but it actually was read quite a bit. It was like a manual, a 101, how batteries are going to change everything about your business for grid operators and small utilities in Germany.
And it turns out they already are.
They already are, and it's still, although batteries and stationary batteries have been around for a decade. Back in my uni days when I was at the lab leading that group, we were building a 5 megawatt hour system back in 2012. Plan, build, the whole development process, pre-qualification, operation, 3 lawsuits with the suppliers because, like today, nothing worked when you're building big batteries. So we've gone through the entire process. Yeah, it's been a lot of fun. And interestingly, even though this has been around for a decade, a lot of energy companies still don't really understand what's going on and are not very well prepared for what's yet to come.
So I'm going to set the scene here a little bit. We've known each other for a little while, and Accure and Modo actually are quite similar but do very different things. There's a Venn diagram where with 2 circles, which are probably touching now, not quite overlapping, but there might be an overlap at some point in the future. And what we do at Modo is we look at how batteries are performing in the markets. And what you guys do really, really well is looking at how batteries are performing in the real world, the physical world. Do you want to just talk for a little bit about what Accure does and what the journey's been like since you started this crazy adventure?
So if you think about lithium-ion batteries, there's one really unique thing about them compared to all other energy assets like wind farms or solar farms or whatever. Every lithium-ion battery is basically an IoT device because it has the small chip, the BMS, that continuously measures voltage, current, temperature, just to make sure you don't overcharge it and push it into a thermal runaway, or that you don't use it outside of the specified temperatures. So it's a really simple logic chip, making sure that you don't abuse the battery. And kind of as a waste product of that process, data is being generated, voltage, current, temperature. And at Accure, we've built a platform that ingests data from millions and millions of batteries around the world, operational data. So really a timestamp, for each day, thousands and thousands of data points, and then uses sophisticated physics-based models, machine learning, artificial intelligence, this whole jazz, to understand what's actually going on with the battery and to predict how it's going to perform in the future. And the three categories that we offer is safety. So is there a physical loss imminent? Is there a thermal runaway on the horizon? Performance, will the battery be able to make the money you hope it'll make, or that you're planning it will? We can talk about what's keeping it from doing that in a minute. And the third one is lifetime. When you plan a project over 15 years, it makes a huge difference if your battery will last for 12 or 17 years. And small changes in the way you treat your battery today can have a massive impact on what's happening in 10 to 15 years. And although that's typically not the most urgent problem for companies today, because they have so many other, much more urgent problems, it's something that carries a lot of value for all companies that think long-term, that not just build a battery to flip it after 6 months, but that really want to own the asset for maybe 15 years.
Is the play here, if I got it right, is if you own or operate big assets, whether that's in electric vehicles, buses, stationary storage, whatever, if you, rather than being a black box, if you fully understand what's happening within them and you're getting data and you can understand that, there's loads of benefits like performance enhancements, you can plan your maintenance, you can make sure you get the right uptime, you got safety improvements, you can maybe extend a few years, your lifetime of these assets. But it's all about collecting the data to start with. And that's what you guys do. How do you collect the data? Where does the data come from?
Standard engineering answer is it depends. For large scale battery storage systems, it could either be a all-in-one supplier like the Fluence and Powens of the world that offer hardware EPCing and also have a data platform that we can connect with, or you might have a separate EMS provider sitting on top of a standard commodity asset. And there's also, I think, a pretty confusing soft stack on top of battery assets that comes with a digital platform that also is a marketing service, or that's only a digital layer. And so there's a few companies also here in the UK providing that part. And so we're typically interacting with the EMS or digital layer
What's the
provider.
EMS? Sorry.
Oh, it's the energy management system. So the part of the system that makes sure that the 60 containers on a site work in unison, and that the signals from the trader are routed to the right containers.
So if we think about big scale, utility scale storage, they might have a load of containers in a field somewhere, 40, 50 containers. Let's say it's a 50 megawatt site. And on that site, there'll be one big computer somewhere, and that will be the site controller. And it'll be figuring out how do you balance between containers and all the complicated stuff. And you guys integrate with that thing and pull the data back to your servers and then do the analysis on that.
Yeah. And so we don't have to tap into the computer on site because all this data is already online. There's very, very few exceptions where it takes work to actually get the data, because everyone knows that this data is valuable, although almost no one is using it yet. So it's typically in a pretty easily accessible place. And then we set up an API, some cloud to cloud connection, pull the data maybe once per day, maybe more often, depending on the use case, run our models, and then we push back the information through dashboards or through direct integration with the customer so they can, close the loop.
Could you just name drop some logos that you guys are working with? What companies? So we can have some idea of the scale. You can brag, right? What sort of companies are you guys working with? What kind of fleets of batteries? Or let's put some scale and some color around what you guys are working on.
Yeah, sure. So unfortunately, some of the most exciting customers I'm not allowed to mention here. A lot of our customers say we're part of their competitive advantage, and they don't want their competitors to know how much better they could be.
That is a good line. We need.
It's
extremely
true.
Convenient and mysterious.
but I can name a few references, and I mean, all in all, as of today, We're mid-July 2023. We're managing about, I think, 2.6 gigawatt hours of battery assets. And by the end of the year, it'll be 4 to 5 gigawatt hours. And I know that you're in Texas right now. You are, right? At least in the
Yeah.
US.
No, I am. You can see me. I'm wearing. I've gone to wearing basically oversized everything.
Yeah.
So I wear t-shirts are like triple XL now, so I can somehow breathe in the heat. Yeah, I am in Texas right now. I had a bagel this morning. That's how American I've become. It's good. It's good stuff.
Yeah, and so you know this better than me. Actually, the ERCOT market for batteries is crazy, and we're extremely successful there. For example, so by the end of the year, we will have about a gigawatt hour, probably more, of battery assets that we support only in ERCOT. And then there's the other American states, and obviously the UK is pretty strong for us. So one company, for example, that I'm allowed to mention is Total Energies, the French, energy giant. We have a few more, but also, you mentioned commercial vehicles, the Berlin Transport Authority, the New York Transit Authority with their electric buses. They trust our services for safeguarding their electric buses. The world market leader for electric ships, a company you've never heard of, but they're actually pretty cool, from Norway.
What are they called? I might have heard of them.
They're called Corvus Energy.
Correct. I haven't heard of them.
And they're competing with Siemens and ABB, and they're winning. And it's like 200 people. So it's awesome. Really impressive.
What's the split then? Like how much of you can do it by customer, or you could do it per megawatt or megawatt hour? Yeah. How much of the revenue that you guys generate comes from stationary storage versus EVs versus other stuff? Because it must be, I'm thinking from a company building perspective, they're very different customer profiles. And it must be quite tempting, because your addressable market of battery stuff is so big. It's like basically the whole energy transition. It must be quite tempting to do products for everybody. The issue with that is, as a business, you're going to lose focus, right? And everyone's going to,
absolutely,
you're better off building something for one or two customers who feel really special rather than everybody. The issue with that is, as a business, you're going to lose focus, right? And everyone's going to,
absolutely,
you're better off building something for one or two customers who feel really special rather than everybody. How do you manage that?
Yeah, no, you're absolutely right. And I mean, the reason why a company like Accure can exist, the only reason is we have to be better than any in-house solution a company could have, and we have to actually be cheaper. And we can be cheaper because we're so highly specialized that we're more efficient. And that gives us, some competitive advantage on that side. To your question, we have, for the last 12 months, had an extreme focus on large-scale storage assets, because from a business case perspective for us, it's the easiest way. It's a no-brainer, right? If you look at ERCOT, for example, 40% of annual revenues occur in the best 30 days of a year, give or take. And so if your battery...
sounds like some tasty analysis. It sounds like it came from Modo.
It absolutely is. So everyone, I mean, these are all customers already, but yes, I highly appreciate what Q and his team are doing here, because we can take your analyses, go to a customer and say, look, what's your average error on state of charge estimation? All these new LFP batteries coming in, and everyone knows they're shitty at estimating how full they are. So if you have a 15 percentage point error, which we see all the time, on the best day of the year, which has a revenue potential of 7 to 10x of an average day, right? If you have 10% error on that day, it's like a full day of being offline any other day of the year. And so although 10%, right, it doesn't sound that much, but if it occurs on the wrong day, you can lose, I don't know, $50,000, $60,000 in a single day. And so you can basically get a full payback on our services in one day of the year. And then you have 364 other days where we're also doing good stuff. That's basically free then. Right?
So can we do a crash course then on
of course.
What's gone on in the last 10 years of battery cell chemistry and what's coming? And I'm going to put some threads into the conversation. So there's a discussion between different chemistries from NMC and LFP, for example. What's the key difference there on a high level? And the buying behavior has changed. There's a lot of LFP systems being built now for storage. Yeah. Is that because the factories have got slots, or is it because it's a better solution? And then what does the future look like? There's a lot of talk of solid state, sodium batteries, lots of other exotic materials.
Yeah.
What is the state of the market right now, please?
The state, it's very confusing for everyone. I'm trying to shed some light on a few things that you said. So NMC, LFP, what does that mean? NMC, nickel, manganese, cobalt, LFP, lithium iron phosphate. These are the cathode materials in lithium ion batteries. If you have an NMC cell or an LFP cell, they share all properties except for the cathode material. So the separator is the same, the electrolyte is the same, the anode is the same, the form factor can be the same. So it's really like a drop-in technology. It's just the cathode material that changes. NMC was the technology of choice. And if you'd asked, or I mean, people have asked that question 5 years ago, when you asked experts, so-called experts 5 years ago, which technology is going to make it, 3/4 of them said NMC is going to be the only one, the only technology that takes the whole market, because there's these synergies with e-mobility. You can put NMC in cars. It has a high energy density, so it gives you a lot of mileage. And because of the economy of scale, it's going to be everywhere. And that was a massive error, right? Because energy storage systems, batteries, were so successful that even stationary storage had its own economies of scale, right? Economies of scale come into a saturation at some point. And if you have enough volume in the market, you can scale several technologies at the same time and profit from these, synergies. And so LFP is a cheaper material. It doesn't need nickel. It doesn't need cobalt. So from a raw material perspective, it's cheaper. There's a few esoteric arguments about which technology is better for long lifetime or fast charging. And the honest answer is there's maybe 500 factors that have a huge impact on these topics, and the cathode material is one of them. So just saying, oh, LFP is a long life material, that's bullshit. It's in the right setup, it can be a long life material, yes. But in the wrong setup, it can be just a shitty battery. So it's not the only point that's important. Now, the one thing that's clear is that LFP has a lower energy density, which means for the same amount of storage capacity, you need more volume, you have more weight. And in stationary storage, it doesn't matter a lot. Typically, floor space is not the main concern. On an island like the UK, sometimes it is, but generally it's not, top of everyone's mind. And therefore, LFP being a little bit cheaper and having drawbacks that don't matter so much, very quickly has become the technology of choice for stationary batteries. And this year we've onboarded, 15 to 20 large-scale storage sites, and maybe one of them had NMC batteries still. Maybe two, but all the new ones, all the big ones, it's all LFP. And I think it's going to stay that way for at least another 2 or 3 years.
The narrative around that, from what I've seen, is that the supply chain issues from the pandemic meant that it was really tricky to get slots in production lines for NMC batteries. And so the tier one suppliers, Fluence and other guys went out and said, okay, well, we'll get some slots for LFP batteries. And before they knew it, they'd built the engineering around the LFP batteries. And that ended up being the battery of choice now because of the cost benefit. And when you're talking about supply chains, I mean, when you can design out the cobalt requirement, for example, that is just something that should be, I know it's a complicated question, but should be a good thing. So how true is the fact that this was a supply chain push to move from NMC to LFP, or was it really that actually LFP is the better solution from a cost basis anyway?
So there's a few factors playing in it. So from a raw material perspective, I would say that most decision makers in this industry don't have ethics regarding their supply chain as their top concern. Unfortunate, but I think that's just true. However, the volatility of cobalt and nickel prices are a big pain for everyone. You want to have predictable prices. And by taking out, the three main volatile components of batteries are cobalt, nickel, and lithium. And so NMC batteries have all three of them. LFP only has the lithium. And so that makes things more predictable. That in itself, independent of the absolute price, a better predictability is good. Then it also has a lower raw material cost. And LFP batteries have slightly lower requirements for production facilities. So you don't need a perfect clean room. It's like one level below that's still okay for LFP. And so it's much easier and faster to scale up. Not much, but it's qualitatively easier and faster to scale up LFP production. Plus, Chinese manufacturers have a lot of experience with that technology, and recent improvements in some details of it have made it competitive. And now you have like the step function from LFP is kind of like NMC's ugly cousin. But then there were a few improvements, and all of a sudden it was good enough for most people. And then boom, they just threw all of their experience into scaling it up, and that was massive success.
So what happens next then? The world got caught out a little bit, although I certainly did. If you'd asked me in 2018, same as you, what was going to win out, it would be NMC. Biggest car manufacturers were betting on NMC. Pretty much all the stationary storage was being designed in that way. And for maturing technology, it felt like the safer option, right? Because people knew how to deal with it to some extent. Yeah. But LFP caught us out. So what's the other curveball that's coming down the way from a battery cell chemistry perspective?
So there's a few contenders out, and I think I would put my money only on one. So I don't really believe in fast or in dramatic breakthroughs when it comes to flow batteries. Maybe I just haven't seen the one that's really promising, but I've seen 10 years worth of announcements that never materialized. So I'm a little bit cautious when it comes to redox flow batteries. Sodium-ion is really the one technology that I believe has everything it takes to be wildly successful. It follows the logic going from NMC to LFP and from LFP to sodium-ion. Lower raw material costs, slightly or significantly lower energy density. However, knowing where LFP was coming from and how they, once it became sexy, it improved. If we can assume a similar learning curve for sodium-ion, and knowing that it's backed by some of the most relevant battery companies on the planet, CATL, among others, if they identified sodium-ion to be of strategic value for them, they're going to make it successful. It's not a question of if, but when. And so I'm pretty confident that sodium-ion will play a small role in the next 2 to 3 years and a major role in the next 5 to 10 years.
What is it? I know that the words sodium-ion are less sexy than the others, right? Sodium could be one of the least sexy words to use in this context, I think. So what is it? And I know that the density is lower, so you need a lot more space. There's some thermal characteristics which are quite different. So but start off with to explain what it is and then how you treat these batteries differently.
So the main benefit of sodium-ion batteries is they don't need lithium, right? So lithium supply has become a bottleneck. It hasn't stopped the battery industry from growing, and it's not as dire as some people claim. There's enough lithium, and with recycling, there's, we're not even close to the end of the curve yet. However, sodium is, like, in its truest sense, abundantly available, right? It's basically table salt. So building a battery technology based on that is extremely attractive from a raw material perspective. It's similar enough to a lithium-ion battery that a lot of the experience we've made with producing and operating these systems can be transferred. It's not a drop-in technology, so the gap from LFP to sodium-ion is larger than the one from NMC to LFP. So we're going to have to make more changes to the production process, more changes to the way we operate these batteries, and so on. But again, since the battery industry these days already is so massive and there's so much more to come, it's pretty easy to mobilize funding for, the next level technology. And I think what sodium ion has to offer is a very reasonable package saying, hey, lower energy density, but also probably lower safety risk at lower costs. For stationary storage and maybe even for entry-level cars, it could be a pretty attractive option.
And is the form factor the same? So if you think about the difference between battery cells and flow batteries, they share the word battery, but pretty much everything about them is different, right? You've got big liquid moving around and tanks and pumps and pressure, and then cells are these smaller things that we all know, basically big Duracell batteries, but in different shapes.
Yeah.
What about this new type of battery, sodium ion? Where does that fit in?
It's very, very similar to the lithium ion batteries as we know them today. And, interestingly, form factor, after 10 years of massive adoption in automotive, in stationary storage, in power tools, like lithium ion batteries, they're used everywhere. Until today, manufacturers still can't agree on what's the best form factor, right? So, and the same manufacturers over the past 5 years have re-engineered their entire tech stack, saying, we did it wrong the first time, but now we're using cylindrical cells because we finally found that they're the answer. And then 3 years later, they scrap it again and start building prismatic cells. So
just to clarify that for anyone who's listening. So you get a couple of types. You get cylindrical cells, which look like big Duracell AAs, right? They are cylinders. And there's some benefits in that there aren't any right angles. So when you're manufacturing, you can roll things. And rolling things from a manufacturing perspective has got lots of advantages. Also, in electrical systems, right angles aren't nice. We don't like right angles. They tend to cause problems. However, there is another type of cell which is called prismatic, which is essentially, think about a half an A4 sheet of paper and a whole bundle of them put together. It's about that size. And it looks a bit like a car battery, but a thin one. You put lots of them together. And they vary in size and quantity per rack and all those things. And there are benefits to that too. There's some safety features you can put in and some other manufacturing differences. And I guess the point here is not one of those is winning, right? If you are just arguing to get as much material into one space like you do in a car, then squarish kind of shapes make sense. But if you really, really care about the other things, then the cylinders make sense. For stationary batteries, am I right in thinking they're pretty much all prismatic, the squarish shape?
Yeah, at least what we see in the last 2 to 3 years. Two massive trends that we've seen is the chemistry went from NMC and sometimes even NCA, so the technology that Tesla had been leading for many years in their cars, sometimes was also used in stationary. Panasonic was the main supplier of that. But so the typical NMC cell that is still installed in hundreds of large-scale storage systems was the LG ES, JH3, JP3 cells. They've been sold hundreds of millions of times. Also had major recalls with General Motors.
Right?
The APS fire in 2019.
Yeah. Let's just talk about that. That's an interesting thing that happened, and you will know a lot about it. So LG sold a ton of these cells. They were installed everywhere. There's lots of systems across Europe, utility scale, that had these cells installed. And they were prismatic ones, weren't they?
Pouch.
Pouch cells, sorry.
Yeah. So pouch is in a soft pack without a rigid container. It's basically like a piece of plastic, and then it's vacuumed.
And they had some issues, right? And it cost LG a lot of money. So what happened there?
Yeah. So several things happened, but to put it short, is LG had some systematic production errors that they were not aware of at the time, and they only found out after there were a number of fires in different applications. So among others, there was probably everyone in the large-scale storage space knows the incident at the Arizona at APS in 2019. That was a Fluent system. And it's so well known because unfortunately there was first responders that were hurt during the response. And so that has triggered a lot of changes in codes and in how first responders work with batteries, which was overdue, but still it's a very, very unfortunate event. And then there was the major recall of Chevy Bolts with LG, also with Hyundai, Kona, and Kia. Hyundai and Kia both used the same battery packs. And so I think there were recalls just in automotive for over $3 billion. Just think about that. That's $3 billion that you didn't expect to spend on something.
To be a fly on the wall in that boardroom and be that poor person who has to stand up and say, we've got to find $3 billion from somewhere. Absolute nightmare.
Yeah. And that person would say, hey, compared to all other options, this is our best one, by the way.
Yeah.
Horrible.
I remember their share price dropped something like 25%. But I mean, the interesting thing, it's from, and I wasn't an asset owner, I spoke to lots of customers who were, but across the board, it felt like they did the right thing. They were transparent about it. General Motors also were transparent about it, and when they did the recalls. And then the UK systems, I don't think from a UK perspective, but the grid scale systems out there that had issues, LG came and swapped them all. So people who built big grid scale assets found that 3 years into their lifetime of doing frequency response, LG was going to come and replace all their cells for them. It's actually pretty good, right? It means you get brand new cells. So hats off to LG for doing that.
Absolutely. And, LG, really, to their credit, for many years has been the leading force in pushing battery technology forward. So right now, I would say most of the innovations or the most relevant innovations are coming from China, from CATL, BYD, and others. But for the largest part of the 2010s, it was really LG and Samsung who were, leading the industry with their technologies. And also, to put it into perspective, there were maybe a few dozen incidents compared to hundreds of millions of cells that they sold over the same, amount of time. And from an engineering perspective, they're impressive still. But of course, it's a danger to the industry if we have more of these incidents. As an emerging industry, it can get you in a bad situation really fast. And so transparency and proactivity is really, of the essence here.
100%. Could you help us with a little crib sheet of which manufacturers are doing what? So we know CATL are going hard at LFP, and they're also investing big in sodium-ion. What groups are the other manufacturers in? And is it broken down by China, Korea, America, Europe, or is it more complicated than that?
I would say you could still break it down by country in terms of country where the company comes from, not what they produce, because the production facilities are becoming international. For example, LG has a huge facility in Poland. There's in Hungary, there's being production facilities in Europe being built right now. CATL has a factory in Germany. And from a technology perspective, so CATL, has a world market share of over 30% now, which is insane. Yes, it might be 35 or even slightly above that by now. So, since we're in a setting here where most listeners will probably be interested in large scale storage, probably 50% of the offers you'll get when you are looking for a new big battery, 50% of that will be CATL batteries. They might be integrated by CATL themselves in a DC container, or they might be in a SunGrow system, or they might be in a Canadian Solar system, or in a, whatever the integrator is called system, but it's always the same battery cell, which is, really interesting. BYD is the same. And then you have, up and coming companies from China, Lithium, Goshen, EVE, Asphalt. They're all not up and coming. They're massive companies with a decade of experience, but for Europeans, they sound new because they're entering the European market just now.
I can't believe that. CATL, 35% of global.
Yeah.
I mean, what an incredible business success for CATL. And also, it was only a few years ago that it looked like BYD was miles ahead. And not far behind that, Samsung SDI and LG Chem were saying they're going to win the market. Going back to the LG thing, actually, it's pretty funny. About 2020 or 2021, I remember being at one of the big shows in Europe, Munich or something like that. And LG had just had the recall, and half of Samsung's stand was about safety. And all the pamphlets are about safety. And LG and Samsung were just going so hard at each other. And it's almost like they missed the Chinese thing.
They did.
So
They missed LFP.
They missed LFP. Okay. I want to talk more about the data. So you guys got loads and loads of data from lots of batteries.
We do.
And you guys probably see stuff that nobody else sees. So can I ask you to share some little tidbits of knowledge that you've picked up? Ideally, really saucy bits of knowledge that only you know.
Yeah, happy to. You're also, a startup CEO. So as a young company, I would say it's more difficult to get the attention of customers, of potential customers. You have to, provide 150% to be taken seriously. And so for us, what has worked incredibly well is we pitch to customers and say, look, here are 10 examples of things that we found with companies like you. However, if you give us the chance to look at, a piece of your data in a limited pilot project, give us 6 months worth of data, we can all but guarantee that we're going to find something that will surprise you, that you never thought possible, and that you will need to change, immediately. And in 100% of the cases, truly, that we started working with a company and they shared some data with us, we were able to identify stuff that they didn't know about, but that was extremely relevant to them. And so, this is the way that we get customers. We show them something that they completely didn't expect, and they're like, oh shit, I got to do something about it. Accure, please help. So, that's the way how we operate. And so what are some of the things that we found?
Before you get there, though,
yeah,
you're a startup, but you're almost grown up now, right? You've got like 100 people-ish. You're operating across lots of different continents. You're almost a big company.
Yeah. Yes, I actually, I don't like the word startup that much because it doesn't communicate credibility or trustworthiness. And, these are the two things that we actually sell. We sell peace of mind, and we sell being experts available at hand when really difficult situations come up and the startup might be too, cloudy. No, but we're about 70 people now, and we operate in Europe, and we have an Inc. in the US. But actually, we have customers on 6 continents. So it's pretty broad already.
But yeah, I jumped in. Sorry, Carrie, you're gonna share all of the golden nuggets.
Well, all of them, we need another few hours, but maybe like a best of. And I actually, anyone who's interested, we recently published a few examples in Energy Storage News, so you can just Google it if you want a little bit more detail later on. We've been doing quite a bit of commissioning support with companies. And, the commissioning phase is so crucial for all parties involved because the EPC will try to get the project over the finish line because then they get the biggest chunk of payment, and only then. And so they're highly incentivized to get site acceptance no matter how. And the owner operator is also highly incentivized because only when the battery is fully commissioned, they can start making money. However, in the process of commissioning and construction and all these things, a shocking amount of things happen, whether it's from battery cell quality that was delivered that's not to specification, BMS errors, imbalancing, and all these things. And so we've been doing a lot of work with companies during that phase. So basically, either with the EPC, who might pay a 6-figure amount of US dollars in a month, sometimes in a week, if they're late with site acceptance. And so if it doesn't work, they really need to find out fast how to fix it. And data is the obvious answer to that question. You have 80 containers, some don't work, no one knows what's going on. Look at the data, right? But typically they're not doing it yet, which is crazy. But okay. And then on the other side, you have companies that might have a $25 million investment. And now, after 1 week of testing, without detailed looks into the actual batteries, it's like, hey, this container, it switches on, yes. And if we press discharge, some electrons go out, okay. please sign here. And what we found in these analyses, just one example, is we did an analysis on the internal resistance of all the cells. And what you would expect or hope for is that they should be pretty close to each other, because it's like a chain. The weakest link kind of defines the performance of the overall chain. And so if one or few batteries have a very different internal resistance, it drags down the entire site. And so we were looking for these outliers, right? So to see if everything is good. And what we found is that very clearly, this site was using batteries from 3 different production batches. So there were like 3 distinct groups with very different internal resistances, and they were just mixed and matched. Like,
wow. Can you say who the supplier was?
No, I can't.
Let me guess. No, it was an acronym. That gets you down from 100% of the market to 99% of the market.
No, so I mean, once we saw the results and we started to ask ourselves, okay, how the heck could this happen? But the answer is pretty easy, right? Most of the batteries that are being produced right now come from production lines that were not up and running 2 years ago. So they're all in the early phase of ramp up, relatively early phase.
Think about this. Yes, this build out of battery manufacturing capacity.
Yes.
You only have to see Elon Musk sleeping on the floor of the factory to know that it's really hard to build manufacturing at scale fast.
It is. And the other thing, so cell quality, I mean, is understandably, there's a certain spread in it. And what manufacturers typically do to get around that problem is they do end-of-line testing, and then they group cells that are similar to each other, and then they pack them up and send them to a site. And apparently that site got 3 different groups of these cells, whereas it should have been 3 times the same group. And then, whether the internal resistance is 5% that way or that way, as long as it's all the same, it's okay. It's not perfect, but it's okay.
So I've got a mosquito flying around during this bloody recording. There's actually 2 mosquitoes, but one's chilling on the chair over there. So I have always wondered this acceptance testing. So you buy a battery, you spend 50 million quid on this thing, and you get factory acceptance testing, FAT, and site acceptance testing, SAT. And you should really spend a lot of money and time in all other aspects of engineering or power generation.
Yeah.
You take this stuff really, really seriously, because if you pick up any issues there, and you usually do, then you can commercially, it's way cheaper to get them dealt with, and you can fix them at source. One thing I have noticed in the last few years is that the world of battery acceptance testing, generally speaking, the manufacturer has got a lot more knowledge than the buyer.
Oh yes,
and that is quite. If you look at gas turbine sales, for example, you can the buyer is usually pretty well informed, or you can buy in that knowledge. But with such an emerging industry and new accelerating emerging technology like battery cells, the control and the power is still in the manufacturer's hands. So, are you saying that you guys can change that using data?
Yes. This is one of the, I would say, no-brainer use cases that we're doing. When you look at a site acceptance form, like, what are they testing for? Okay, you have like hold point testing, black start capability, a shakedown where you maybe just rip out a few communications cables and see if anything, goes crazy. But it's crazy to think that none of the testing concerns the actual batteries. So just looking at whether the battery cell quality you got delivered is to specification is not part of standard site acceptance testing. Why?
We got to change this.
70% of the value of the site. And it's not so difficult, and it's not so expensive to run a few additional tests with a specialized company, right? I mean, everyone's used to having, owners, engineers go over the site and check if, some of the cables are installed as they should be, and check if the water piping is installed correct. But no one yet, or I mean, our customers do, but many companies still don't really pay a lot of attention to the actual battery cells, which is, yeah, I think this will change very soon, but right now it's not a standard yet.
Yeah, we've got a lot of work to do there. You've got to approach these things like it was your money, right? So generally, if you work for one of these funds or, I don't know, a bank that's lending against it, it's other people's money. But if it was your money, if it was your 10 million quid, you would go through everything tooth and nail. One of the things that always surprises me is the amount of assets that are built that have a usable capacity in megawatt hours or kilowatt hours, but it's never been tested. So the manufacturer said, hey, I tell you what, you've got a 1 hour system. We're going to test the capacity. We'll test half of it and you can just double it. Or we'll test the capacity at half power for 2 hours. And look, you've got a 1 hour. And of course, there's so many things that can go wrong when you're at full capacity for a step, like a step wave. But still, we're seeing sites come online that have never been put through a full power discharge for an hour. And then you put them into traded markets and they fall over.
Yeah, they all trip like thermally, produce too much heat, and then it gets hot and they switch off.
But it is starting to get better. It is starting to get much, much better. And I think asset owners are incredibly sophisticated and in the know now in a way that they weren't a few years ago. What would you advise people? So we talked a lot there about site acceptance testing or testing your site before it comes online. So what would you advise people to do? What are the tests that are really important?
The whole testing that's being done right now in terms of mechanical, electrical, I mean, this is all very important, right? If the transformer isn't connected properly, the site won't work, and it's also a major safety hazard. So all of these things, they're still needed, right? I don't want to say let's just use data and get rid of the rest. No. What I'm saying is that currently the tests are treating battery sites like traditional assets, like a gas turbine or like a wind turbine, not acknowledging that there are some additional complexities coming from the electrochemical part of the site. It's not just about loose nuts and, disconnected water pipes, but also the electrochemistry going on. And what's really cool is that can be solved really fast. It doesn't add time to the commissioning process. It adds a little bit of costs for the services, but every single time we've worked with a customer, they saved several X the amount of money that they paid us for investigating, right? Either because they found some shortcomings of the site where they got reimbursement from their supplier, or they were able to go to the market faster because some of the problems they had been working on for weeks and weeks could be solved in a day all of a sudden, because we were like, hey, you're aware that module is just broken. You're not going to balance it healthy, right? And they were like, yeah, that's kind of what we were trying. So let's just replace it. And then, you have all the information. You can make smart choices. Regarding factory acceptance testing, no clear standards. And again, there's a huge, it's a seller's market right now. So there's a limited leverage that buyers have, and the manufacturers really don't want to share more information than they absolutely have to.
What does that mean, a seller's market?
Oh, right now, if you have a battery production line that can pop out batteries at an acceptable quality, you can pick your buyers. So, when there's more sellers than buyers, the buyers can be picky and can put some more requirements on the deal. But I mean, CATL is in a very, very good position right now. And if they don't want to share information with you, they're just going to move on to the next buyer.
Yeah. So if you're going to spend this $100 million on a battery, and in the tender documents, you go out to CATL, BYD, all of those, and you say, right, what's really important to me is I want a really great quality battery, but I also want access to all the data around the temperatures and the voltages and how these cells are behaving. And the supplier, CATL, or I'm not picking on CATL here, but they're just the biggest, so it's easy. Yeah. They can say, look, if you want to buy from us, we're not going to give you that. But trust us, we'll look after the batteries in your service level agreement. But we're not going to give you access to all that data. You don't need all that data. And if you want a slot in our production line, you're gonna pay for it. I don't know. Yeah, you're right. It's good for manufacturers. I'm not sure it's good for the ecosystem.
It isn't. And actually, the one company that has been doing that hardcore is Tesla. Tesla doesn't give access to the operational data of their assets to the people who own the asset, which is crazy. I mean, after German law, they would be the rightful owners of that battery, and Tesla holding back that.
But then again, right? It reminds me of a little. It's like the PC versus Mac thing, right? If you said to Steve Jobs, right, you need to start telling us the temperature of your cores in your graphics card on all of your Macs, he'd say, no, forget it. I'm gonna keep it running for you. I'm gonna give you a beautiful user experience.
Yeah.
But there's no way you're gonna have that. And it kind of feels the same way. I'm aware that we've gone well over time here, and you might have something more important to do. In fact, you probably do. I want to ask you the two last questions. The first one, this is your chance to plug something. So any big deal, sale, or some announcement, now's your chance. And then I want to ask you the most important one, which is, what is your contrarian view? But firstly, what's your plug?
Yeah, so we have a nice announcement that came out in several charges over the past year. We have a very successful cooperation with HDI Global, which is one of the leading insurance groups in Europe, and they're active in over 100 countries. And they are recommending us as a risk-reducing measure for battery systems. And they are giving better insurance conditions that can include other obligations and can also include lower premiums. And,
wow. Congrats, man. That is huge.
Yeah. Of course, it's a case-by-case decision in every case. Like, insurance, no two contracts are the same. But for us, it's a nice backing, by such a conservative and risk-avoiding stakeholder to get their trust. And we're the only company in the world who has achieved something like that so far.
What an endorsement to enhance your credibility. You guys must be doing something right. Very well done to whoever signed that deal. Okay, so what's your contrarian view?
This might be a little bit battery nerdy, but maybe also interesting for the folks that stuck so long in the podcast. So to the last 25% that are still listening.
Our listenership is pretty niche, don't worry.
So, and that actually goes back all the way to why I started this company with a few colleagues, because the contrarian view is testing a battery, like physically testing a battery in a lab, will get you worse results when predicting the future than doing nothing at all. So more information will lead to worse decisions. Contrarian enough?
My brain's broken. Why?
Okay, so, the traditional way to predict battery behavior is you get 50 to 100 cells in a lab, and then you test them under different conditions. And, one you test while it's very hot, one very cold, one with a high C rate, full cycles, part cycles, and then you bring all the information together in a model, and then you can say, well, if I add another 20 full cycles, looking into the lookup table for my testing, this will degrade the battery by 0.02% or whatever. And if I increase the temperature by 10 degrees, this will kick up the aging rate by whatever, always referring to the results from the lab test. Okay. And it makes a lot of sense. However, if we take one step back and we look at the setup that we're just trusting, where do these cells come from that you test in a lab? You go to your supplier and say, hey, I want to buy 50 million quid of batteries from you, and I would need just 100 specimens to test them in my lab before, so could you just send a few over?
Let's see where this
Which
is going.
cells are they going to send you? They're going to pre-test the shit out of 500 batteries and send you the best 100. Yeah, really making sure that there's nothing out of the ordinary that you could find there. And now you're doing all these tests and you're thinking, man, I really got this.
Dude. This is like Volkswagen diesel cheating scandalous.
Well, you can't force them to give you realistic batteries. They're handing you what they want you to see, right?
No, I can imagine everything you're saying is true.
Yeah. And now, if you're doing all these tests on this cream of the cream split of the battery production, you're priming yourself to expecting that all the others will be just the same, because that's how a model works. Like, you build a model and then you assume it's valid. But in reality, the battery that gets you in the news because it burned down, or during a heat wave in Texas, it just didn't work, and now you had a blackout, all these nasty things. They are caused by the batteries that you will never get for testing. These are the outliers that kind of, oh shit, we need another 10 megawatt hours for that customer, but we don't have the AAA grades. Yeah, just fill it up with whatever comes. Right? And so that's why at Accure, we believe building our models based on tests makes it worse. Instead, we're looking at each individual cell behavior, and we're building the models on the fly so that we also include the weird ones.
That is absolutely fascinating. My brain's broken. There's a healthy dose of cynicism in there, but I think measured and appropriate. So, KP, I just want to say a massive thank you for coming on the pod. We're going to have you on again because we didn't cover 80% of what we're going to talk about. There's so much stuff we didn't talk about. But I want to say from our side, from me to you, it's been great watching your journey. Glad to be your friend and seeing Accure go from strength to strength. And we're going to have you on again soon. That was brilliant. So if you're listening to this...
Thank you so much.
If you're listening to this, hit all the good buttons, like, subscribe, all that stuff. Yeah, it really matters. Cheers, guys.